Hey everyone, and welcome. Today we're going to crack a code that you literally use every single day, probably without even realizing it. I'm talking about the secret math behind every perfect picture on your phone or computer.
You know what I'm talking about, right? You try to resize a photo and suddenly your friend looks super stretched out, or your poor cat looks totally squashed. It's so frustrating. But what if I told you the reason it happens and the secret to fixing it is all about a really cool and simple math idea?
Okay, so just look at these two tigers. The one on the left looks awesome, powerful, majestic, just like a tiger should. The one on the right? Not so much. It looks like it's been stretched in a funhouse mirror. They're the same tiger from the same original photo. So what gives? What's the real difference here that makes one look so right and the other just so wrong?
All right, so here's how we're going to figure this out. We'll start with our tiger mystery. Then we'll uncover the secret of what's called proportion. After that, we'll learn the language of ratios, see how to use this stuff in the real world, and we'll even dig up an ancient math secret. It's going to be fun.
Okay, first up, the case of the distorted tigers. Let's dive into why some images just look right and others, well, don't. To really solve this, we can't just trust our eyes. We've got to bring in some numbers.
So let's actually measure these things. The tiger that looks good, image A, is 60 millimeters wide and 40 millimeters high. The distorted one, image B, is 40 wide and 20 high. Now, obviously the numbers are different, but that's not the important part. The real secret isn't in the numbers themselves, but in how they relate to each other.
And that relationship, it has a special name. This is where we get to the heart of the matter, the big idea that explains this whole mystery.
Here's the secret, plain and simple. The good images, their width and height have been changed by the exact same factor. Think about it. If you double the width, you have to double the height. If you shrink the width to a third of its size, you have to do the same to the height. If you don't, you get a wonky-looking tiger.
And that brings us to our big word of the day, proportional. When two quantities, like width and height, change by that same factor, we say they are proportional. It's a really powerful idea. When things scale together perfectly, they stay in proportion.
Okay, so how do mathematicians actually talk about this stuff? They have a really neat and tidy way to describe these relationships. Let's get into the language of ratios.
They use something called a ratio. A ratio is just a way to compare two quantities. Super simple. So for our good tiger picture, the ratio of the width to the height is just 60 to 40. We write it with a colon in between. 60 colon 40.
And this is where it all clicks into place. When you have two ratios that can be simplified down to the very same value, then we say they are in proportion. It basically means they're describing the same exact shape, just, one's bigger and one's smaller.
Let's break this down. On the left, we've got ratios that are proportional. The ratio 60 to 40, well, if you divide both numbers by 20, you get 3 to 2. And look, a smaller picture that's 30 by 20, that also simplifies to 3 to 2. See, they're the same. They're in proportion. Now look at the right side. Our original tiger is 60 to 40, which we know is 3 to 2. But the squashed tiger is 40 to 20. If you simplify that, you get 2 to 1. And since 3 to 2 is definitely not the same as 2 to 1, they are not proportional. And that is exactly why one looks good and the other looks so weird.
All right, so this is great for fixing our photos, but this whole idea of proportion is way, way bigger than just that. We can actually use this same exact thinking to solve all kinds of real-world problems.
Okay, check out this real-world problem. A school cook needs to make rice. They know that 15 kilograms of rice is enough for 120 students. But today, only 80 students are showing up for lunch. So the big question is, how much rice should the cook make? You don't want to make too much, but you definitely don't want to run out. This isn't just a guess, it's a proportion problem.
So we can set this up using the language we just learned. The ratio of 120 students to 15 kilograms of rice should be proportional to the ratio of 80 students to, well, some unknown amount of rice. Our job is to figure out that question mark.
And to find that missing number, we're going to use a method that is so powerful and so ancient, it was basically a mathematical secret weapon back in the day.
So let's jump back in time. We're talking more than 1,500 years ago. A brilliant Indian mathematician named Aryabhata came up with a fantastic method for solving these exact problems. He called it the rule of 3, because you always start with 3 numbers and you're trying to find the fourth.
And check this out. Here's his rule. He didn't just use boring terms like A and B. He gave them these cool, poetic names. The pramana is your starting measure.
The pala is the fruit or the result you get, and the icha is the new amount you want or requisition. It sounds complicated, but his rule lays out the steps perfectly.
So let's use his ancient method to solve our rice problem. Our starting measure is the 120 students. The fruit is the 15 kilograms of rice. And our new requisition is the 80 students. So Aryabhata says, multiply the fruit, that's 15, by the requisition, that's 80. Okay? 15 times 80 is 1,200. Then divide that by the original measure, which was 120. And 1,200 divided by 120 is 10. There it is. The cook needs exactly 10 kilograms of rice. Pretty cool, right?
You know, what Aryabhata called the rule of 3 is something we still use all the time today. We just call it cross-multiplication. It's the same exact idea. If you have a proportional setup, like A is to B as C is to D, then A times D will always equal B times C. It's a timeless piece of math that worked 1,500 years ago, and it works perfectly today.
So there you have it. We went from a squashed tiger picture all the way to ancient Indian mathematics. But the main takeaway is that this idea, proportion, it's literally everywhere. It's in the recipes you follow when you cook, it's in the maps you use to get around, it's even on the screen you're looking at right now. So, I'll leave you with a question. Start looking around your world. What can you find that's designed to be perfectly proportional?